Three heavy space vehicles are being developed by the National Aeronautics and Space Administration under the project name Saturn. The first configuration, known as Saturn I, consists of a booster called S1 with 8 H1 engines, plus an S4 stage, the instrument unit and payload. A second configuration, Saturn IB, consists of a S1B first stage, plus an S4B upper stage, an instrument unit and Apollo spacecraft. This film report, number 15, will cover progress on the Saturn I and 1B during the period January through March 1963. Slight changes in the names of Saturn vehicles were announced by NASA during this quarter in the interest of simplification. New designations for the Saturn C1, C1B, and C5 are now Saturn I, 1B, and 5, respectively. The fourth Saturn I flight vehicle, SA-4, was shipped from Marshall Space Flight Center aboard the Saturn barge Promise on January 20th, bound for Cape Canaveral. En route, the barge encountered heavy seas in the Gulf and tied up briefly at Fort Pierce, Florida. It arrived at the Cape on February 2nd and was erected on the launch pad the following day. Highlighting this report period on March 28th was the successful launching from Complex 34 at Cape Canaveral of the fourth Saturn I launch vehicle, SA-4. Several minor technical difficulties during the countdown, mostly in ground support equipment, delayed the firing about 1.5 hours. While the SA-4 flight shown in slow motion was similar in many respects to that of earlier Saturns, there were several significant departures. At 100 seconds following liftoff, engine number 5 was deliberately cut off, but the vehicle held on course while the propellant distribution system channeled the remaining fuel into the other 7 engines, extending burning time 2 seconds to compensate for loss of thrust. Several other changes in the vehicle will contribute to the development of the Block 2 version of Saturn. Some components of future Saturns were attached to the inert second stage. Control accelerometers were used actively for the first time. Flown as a passenger was the engineering model of the ST-124 stabilized platform, which will be used actively beginning with the 6th Saturn. A Mistrum system transponder was also flown on a passenger basis. A cue-ball angle of attack device was mounted in the nose cone, and several sections of new heat shield insulation at the tail section were tested. SA-4 reached maximum altitude of 81 miles, range of 232 statute miles, and a peak velocity of 3,847 miles per hour. Meanwhile, at Marshall, 3 static firings of the booster for the 5th Saturn flight vehicle, SA-5, were conducted. The first, for 32 seconds, was successful. The second firing was conducted for a period of 143 seconds. However, propulsion system deficiencies appeared in data analysis, and corrective action was taken. On March 27th, a third firing of 144 seconds was successfully performed. Results indicated that the deficiencies had been corrected. More than 1,000 measurements of propellant flow rates, temperatures, vibration levels, and other data were recorded during the firing. The SA-5 booster, first in the Block 2 series, is the initial flight booster to be static fired at full thrust of 1.5 million pounds. Dynamics testing of the complete Block II vehicle, SA-D5, began at Marshall in January and was completed early in March. Next quarter, dynamics tests will begin using Saturn I upper stage and boilerplate Apollo. As the Saturn hangs on giant cables and coil springs, it is put through paces which simulate flight conditions. As the vehicle bends rhythmically or vibrates, driven by a large electrical device, stress measurements are taken at vital points all over the vehicle. Results of testing are fed into an analog digital computer, which changes data into digital numbers on magnetic tape. The tape is then run through another computer, which prints the results for immediate study. Following first phase testing, the booster was removed from the test stand and will be shipped to the Cape in April for use in Launch Complex 37B checkout. Complete vehicle testing will be resumed in June. At Marshall's Propulsion and Vehicle Engineering Division, an SA-5 type instrument unit was mounted for structural testing between a Douglas-built forward interstage and a spacecraft adapter, simulating flight hardware. Flight loads incorporating adequate safety factors are applied to assure proper structural performance in actual flight. These flight loads consist of aerodynamic, inertial, and internal pressure loads. Stresses produced in this structure are measured at several hundred points and recorded for analysis. A duplicate of this instrument unit will be flown on SA-5. Testing of the new combination support and hold-down arms for Block II launch pedestals began at Marshall this quarter. The first set was delivered to Complex 37B in January. Testing of a second set was suspended when cracks were discovered on the upper part of 5 arm castings. Recheck of the set at Complex 37B and a third set of arms under fabrication showed no defects. The SA-5 booster mock-up was shipped by barge on January 25th from the Marshall Center to its Michoud operations at New Orleans. There, the mock-up will be used by engineers in design verification and to familiarize assembly personnel with the Block II configuration. The booster for the 6th Saturn I flight vehicle, SA-6, was completed this quarter at Marshall's Manufacturing Engineering Division. Several vendor-supplied parts not available during assembly are being installed during checkout, which is to be completed in early April. Assembly of the booster for the 7th Saturn flight vehicle, SA-7, begun on January 7th, preceded this quarter with clustering of tanks completed and installation of engines underway. Meanwhile, fabrication of the booster thrust structure and interstage adapter for SA-9, the 9th Saturn flight vehicle, is complete. For SA-9 and SA-8, a 2-ton meteoroid detection satellite is being developed by the Fairchild Stratus Corporation, Hagerstown, Maryland. During launch, the satellite will be housed in the service module. Flight experiment results will provide a better understanding of meteoroid hazards encountered in spaceflight. After injection and separation of the boilerplate spacecraft, the satellite remains attached to the S4 stage and deploys 2 large flat wings, 10 feet wide, with a total wingspan of 96 feet, by a system of scissor-like links driven by an electric motor. The wings will be covered with sheets of aluminum of varying thicknesses up to 16 1/1000ths of an inch. The back surface of the sheet is covered with a thin layer of mylar and its back surface coated with a thin layer of vapor-deposited aluminum. An electric potential is established between the outer skin and the inner aluminum coating, charging the entire unit, making it a huge capacitor. Each time the wings are penetrated by a meteoroid, the material removed by the impact vaporizes and forms a conducting gas which discharges the capacitor. The pulse is stored in a memory circuit and transmitted to a ground station on command. Solar panels supply needed energy for power. At Marshall's Michoud operations, S-18 tail section assembly was completed this quarter. Assembly operations will begin in May. Meanwhile, S-110 barrel assembly has been completed, and the outriggers and remainder of the tail structure are being assembled. On February 5th, a decision was made to modify the west side extension of the S-1 static test tower, originally designed to test S-1 boosters. The extension will be slightly modified to test F-1 engines, enabling testing to take place several months earlier. After completion of Marshall's F-1 test stand, the west side will be reconverted for S-1 static testing. Radiation pattern testing of various Saturn antennae is being carried out at Marshall's radio frequency test range. This service structure rolls on rails, is propelled by an electric motor, and is easily maneuvered by one man. Its purpose is to afford access to the model for positioning, adjusting, or making modifications. The facility is used to measure and record the directional properties of the vehicle's antennae. The pedestal-mounted model is rotated continuously during the time that a radio frequency signal is being transmitted to a receiver at a fixed location. The varying amplitude of this signal is recorded at a console located in an adjacent building. At Marshall's Astrionics division, Saturn booster H-1 engines are being tested on the H-1 engine cold calibration test stand, enabling engineers to simulate actual flight conditions of Saturn's S-1 stage. The hydraulic actuation control system positions the engine to the angle commanded by the vehicle guidance system. This positioning is necessary for attitude control in the pitch, yaw, and roll planes, stabilization, and to reduce bending of the vehicle. Test results will help determine if the flight control circuits and mechanical power converters are adequate to satisfy vehicle requirements for flight. The S-4 facilities checkout stage was shipped from the Douglas Aircraft Company, Santa Monica, California, to Cape Canaveral early this quarter. The stage is ready for use in checkout of facilities at Launch Complex 37B. On February 1st, the all-systems vehicle was shipped by water and overland route to the Sacramento test facility for propellant loading tests on Test Stand 2B. After initial testing, the vehicle will be removed from the stand and equipped with RL-10A3 engines for further testing. At SACTO, S-4 battleship testing with flight type RL-10A3 engines began in January. During this report period, 7 firings were performed, 4 successful and 3 partially successful, for a total of about 2,000 seconds. Difficulties were encountered during February with helium heater ignition, engine purging, and small fires resulting from hydrogen leaks. After correction of these deficiencies in March, a series of 3 successful propellant depletion firings of over 460 seconds duration were performed. Due to these problems, the battleship firings have been extended through April. Checkout of a new test stand designated B6 has been completed this quarter at Pratt & Whitney Aircraft's Florida Research and Development Center. The stand is designed to permit both transient and steady-state tests of turbopumps without actually firing the RL-10 engine. Liquid hydrogen and liquid oxygen can be supplied to the turbopump, and high-pressure gas storage is available to drive the turbine. Test results are recorded by automatic data equipment. Vibration tests were performed on the latest version of the RL-10A3 engine. Instrumentation for these tests included 40 accelerometers, plus load cells at the actuator arms and at the gimbal spool. The tests were conducted with vehicle equipment, including the hydraulic pump installed on the engine. The engine was vibrated in axial and lateral planes to levels appreciably above those encountered in Saturn flights. No structural weakness has been discovered in these tests. At Douglas, Santa Monica, a full-scale S4B engineering mock-up will be used to verify flight-type system compatibility with ground support equipment. Both tank domes are now complete and are installed in handling jigs. The forward interstage structure is attached to the forward dome and the aft skirt to the aft dome. Fabrication of a number of production tooling fixtures and manufacturing of the first hydrostatic vehicle is underway. The testing program for the S4B vehicle includes research, development, qualification, production, and reliability verification testing. The design concept for the Saturn IIB instrument unit, which will be located between the S4B stage and the Apollo spacecraft, has been established by the Marshall Center, and detailed design work has begun on several components. All equipment will be mounted around the periphery of the unit, which is 3 feet high and 21 feet 8 inches in diameter. Circulation of a coolant through panels to which equipment is mounted will provide temperature control for the instrument unit as well as for adjacent S4B stage equipment. The instrument unit will house the major guidance and control, tracking, and telemetry systems. The unused volume in the center will allow the legs of the Apollo's lunar excursion module to extend into the unit, thus making the total Saturn IB vehicle shorter. At Rocketdyne, contractor for the J2 engine for the S4B stage, a relatively new manufacturing technique in metal forming called electrolytic erosion is underway for production of J2 injectors. This concept uses a forming die made of compressed graphite, which in turn acts as an electrode. As the erosion process reacts against the metal to be formed, a non-conductive oil removes the eroded material to planned tolerances. At Cape Canaveral, work on Saturn launch sites is progressing as planned. Launch Complex 34's umbilical tower is near completion. Meanwhile, overall construction on Launch Complex 37 is on schedule and Pad B is virtually complete.